All right. Okay. This one here, it's kind of hard to see what's going to happen with this, and later on we'll have a little bit easier test to use on this one. But this is the question. If you're going to use the alternating series test on it, then you have this question: how do you find this limit? The fact is, no matter what test you're going to use, this is probably a quotient that we need to know the limit of. So we can look at it like this. Let's expand this n factorial. So 1, 2, 3, 4, 5, 6, all to n. 2 to the n, of course, is 2, 2, 2, all the way out. So the question is, for what value of n does this thing show some kind of a direction as to what's happening? Let's write this out like so. To start, 1, 2, 3, 4. Let's go out to 1, 2, 3, and then leave this as 4, 5, 6, and so on. And now this is about 6 right now. And this over here, if we expand out the first 3, we'll have this. And now what you notice is this is n minus 3 factors still in here, because we originally had n factors, and this is an 8 in here. Okay, so what it looks like is it's so far, if for n equals 3, that n factorial is actually smaller. Let's see. Well, let me just write it out. One more. Here, let's do 1, 2, 3, 4, and then leave the 5, 6 out to n. And now this is 4 factors, and this is n minus 4 factors. And over here, I'm going to write this as, I'm going to pull out one more of these 2's and make this a 16 times 2, 2, 2. And this will be, and also n minus 4 factors. Okay, so what we have is a 2, 6, 24 times this number here, 5, 6, 9. So when you compare these two, we have n factorial equal to 24. Excuse me, 24, and then 5, 6, 7 out to n, and you have 2 to the n equal to 16 times 2, 2, 2, all the way out to the n. And these are the same number of factors, n minus 4. So you can see that at least you see for n greater than or equal to 4, we have n factorial over 2 to the n must be greater than 1. Since in here, this number, the 24 is bigger than the 16, and each of these factors in here matched up is bigger than the 2 underneath it. So this ratio up here does not go to 0. That means this series will diverge by the nth term test. Now you can do a similar treatment for n factorial over 3 to the n and 4 to the n and so forth. But similar to this approach, it's a little harder to do in general for k to the n, but we'll have a test later in the chapter where we can actually show n factorial over k to the n. That limit does not go to 0. We can show that in general for any size base here, k to the n, any base k. So anyway, divergent by the nth term test.